Well, good morning, everyone. Today we're going to be hooking up the solar panel to fast charge the phone. I had some testing going on my converter yesterday and it looks like it'll work just fine for this project. So right now we're going to wire it all up and get it working and get the phone fast charging and show how that works. This is going to be fun. Untangle this mess of wires I created yesterday. And we're going to need the screwdriver. First, I'm just going to disconnect the panel so that we don't accidentally get some short circuits. Might as well disconnect all of these little wires because I'm going to redo it anyway. Now this panel did come with a solar charge controller, but I don't think I'm going to be using that because it just doesn't seem to be the right voltage for the battery that I bought. So we're just going to do it all ourselves instead. So I've got a little Druck DC to DC puck converter here. I think these go for about $15 based on my memory. And we're going to use that as the main brains and power source, or well, power converter. This is what's going to convert our electricity to something that the cell phone can use. And we're not even going to use the battery at all. Instead, we're going to use a couple of really big capacitors that I got over here from an old projection TV. Look at that. Oh, it's on manual focus. Look at that, 250 volts, 1500 microfarad. Those should provide us with the required capacitance to deal with birds flying in front of the solar panel and dropping the power out just a little bit here and there. Just give it a little bit of extra oomph that it needs to keep the charging going. Let's see here. Just had a coffee, so now my hands are jittery again. We don't need any of this. Usually I would desolder these, but there's really no point when you're not keeping the circuit board. You don't want to breathe that. There we go. That cracked right along the edge there. Made it easy to pull off one of the terminals. We're pulling off the copper now. Actually, we're pulling apart the multi-layer board. There. Got one off. Now we'll pull off this other one. You gotta be careful because this is sharp. All of these little wires here will poke you and cut you and cause annoying little holes in your skin. You gotta be real careful, because otherwise there'll be blood everywhere. Now we don't need any more of those capacitors. Some of those are nice, but they're all in the 400 to 500 volt or high voltage range, and they don't actually have very much capacitance. So you just need those two. I'm gonna snip off excess circuit board here. Should be able to get it clean enough to remove all the circuit board, but even if you don't, it doesn't really matter that much. We just need to be able to attach some leads to those with our soldering iron. Garbage can? Awesome, thank you. Needed that. I was making a little pile of garbage. It'd be a lot easier to remove this with a soldering iron and a bit of solder wick, but I don't have any solder wicks. We're going to do it this way. And besides, not everybody has soldering irons and solder wicks. Probably not everybody has these capacitors also for this project, especially from Nippon Chemicon. These are nice capacitors. I believe they came out of a Sony projection TV. Here we got one all nice and clean. And now we'll just do the same thing for the other one, and we'll have two capacitors ready for this. It is really nice to sit down and do a project and have literally all the tools you need to do it properly. Alright, I need to run a power cord for the soldering iron. So we're going to attach a couple little wires to our capacitors here. That's going to heat up a little bit more there. I'll solder all the leads on at once. Remember, don't breathe, the solder fumes are not good for you. There's one. Not the best of soldering job, but it works. Hopefully that isn't overheating my capacitor too much. They are somewhat temperature sensitive. That one did not attach properly. Blowing on it to cool it down. That should be all the soldering for now. I may add a diode to this just to make it a little less likely to be wired backwards, but that's not that big of an issue right now. Alright, now hook up the capacitors to our terminal block along with the solar panel. I had zip ties, but it looks like they're in another box. I'm going to use tape instead. That coffee really is making my hands not work properly. Stupid coffee. Why do I drink you? I know I said I wasn't going to use this charge controller, but I'm going to try hooking them both up at the same time actually. See if I can hook up my 12 volt battery and the charge controller here, or the DC to DC converter here, and see if I can get them to charge both my phone and the lead battery at the same time. This one off for now. That's going to hook up to the battery. Give myself a little extra space here. Positive, positive. Double check to make sure that they go both. Positive, positive, positive. Yep, it's good. Because if you reverse polarity some of these, they might blow up. Or, well, just die and release their magic smoke and never work again. Because I don't think I paid for the extra nice ones with input protection. Well, there was some charge in the capacitors. Now there isn't. Very cool. Alright, so we hooked up the lead battery to the charge controller here. Our positive lead here. Actually, it should have some wires in here. Yep. One. Alright, here's the one I needed. So disconnect these wires because we're not going to use those like that. Should fit right there. Now it's not exactly the right size, but it works just fine. Cut that in the middle. What kind of wire is this? Always be careful when using the knife. So that wire isn't really designed to be stripped. It's kind of annoying. And this one. I don't have the correct wire strippers, so that might be a factor as well. These might be too big of wire nuts, but they will do. There's one. Alright, we're almost done here. Next thing we gotta put in these wires on the battery. We're going to do some experimenting to see whether or not this works like this. I might change the wiring so that this plugged into here, but we'll see how it goes for now. So, this is our positive lead here. That one's going to go on the battery. And then we have our negative lead here. black. And we have a red light. Something. Probably done with the terminal block for now. Cover it up. Alright, we're ready to try it out. Let's hook up the voltmeter over to the capacitor bank side, even though it's not really that interesting. I don't expect anything on here yet. Yeah, -3 volts. We gotta flip over the solar panel now. And right on cue, the clouds come in. Alright, it's all working. It's working perfectly. Right now, this battery is not connected because it's just on the side there so that I can drop it on when I want to start charging the battery. Well, what we've got here, from here it comes down the wire from the panel. That goes into the terminal block here, which is connected in parallel with the capacitor bank. And then the power is split off from here over to the solar charge controller for the battery, which is disconnected right now, and then goes from there over to the puck converter. And then the puck converter here is cycling its input-output voltage display right now. It's currently putting out 7 volts, 0.37 amps, about 2.5 watts, 10 volt input because it just got cloudy. And then that runs through my really long, stupid charger cable up into the phone. You can see that that's not going somewhere. And then, now the phone it's not charging very fast right now because we just lost our sunlight. But as soon as the sunlight comes on, I'm going to cut and we'll see what it actually charges here. Alright, so the sunlight is back. We're actually fast charging now. Take a look at that. Coming in at 1.5 amps into the phone. Currently got 19 volts DC out of the panel, but that fluctuates wildly as the sun comes in and out. But the capacitor banks are actually helping a lot with that, making it so that it doesn't drop out instantly. And we are fast charging now at a rate of probably close to 45 minutes for a 70% charge or so. Anyway, that has been how to charge your phone off a solar panel without a battery. Let me know what you think. If you have any comments, if you tried buying this yourself, this is the eco-worthy 25 watt solar panel kit off of Amazon, going for about 60 bucks right now. The puck converter was an additional 20 bucks. I'm not actually using this at all right now, so you don't really need that. You just need the panel and the puck converter. So thanks for watching. Leave a like, subscribe, and all those things. And there's going to be daily videos now for all kinds of different survival stuff and lots of stuff to watch. See you all soon. Yes. Thanks for watching.